Okay, there's two types of ionic compounds we are going to be dealing with. Okay, the first one is a binary compound. Prefix bi means what? Two. So this is a compound with two elements. And again, these are only ionic compounds. So we're always going to be dealing with a cation and an anion. Okay, so binary ionic compound has two elements. It's going to have a metal in the front and a non-metal in the back. The second type of ionic compound we're going to be dealing with, it's called a ternary, T-E-R-N-A-R-Y, ternary ionic compound. And this type of compound will have three or more elements. You're going to have a combination for this one. But I guarantee you, if it is a ternary ionic compound, there is a polyatomic ion present somewhere. Okay, whether it's in the front, whether it's in the back. If it's a ternary ionic compound, you're going to have three or more elements present. And in binary, you're only going to have two elements. You'll have a metal in the front, a non-metal in the back. And these are the types of compounds that we are going to name and write formulas for. So we're going to start by writing formulas. Okay? And I'm going to move back to that in just a second. So first thing I want you guys to do, and I don't know, maybe I can make that a little bit bigger. Can you all see that? Okay, so go ahead and write those down so you have them in your notes for examples. That way when we start doing examples, you don't have to write the name. So we're going to start with the name of the compound, and then we are going to write the formula that goes along with it. Now, I just think it's easier just to jump in and just do a whole bunch of examples. On Google Classroom, I have step-by-step, okay, of how to do this. So if you feel after we are done doing all of these examples, if you feel like you need to go and write down the steps, by all means, it is there for you. But I think you're going to catch on pretty quick. Thank you, Lucas. Appreciate it. Okay, just a quick reminder, oxidation numbers are just the charges on an ion, on the polyatomic ion. It's on your list. If it's an element, it is on the periodic table. If it's a main group element, you have the oxidation numbers. I'm pretty sure we wrote them above each group. And if it's a transition metal or tin or lead, we're going to find the oxidation numbers just above the symbol. Okay? So a few things before we just jump into this. If the ending is IDE like this, okay, IDE, I'm not going to say 100%, I'm going to say 9 times out of 10, okay, this anion is an element. So if it ends in IDE, it is most likely an element. Not always, because you've got a polyatomic ion named cyanide, you've got hydroxide. But most of the time, if it ends in IDE, you're looking for an element in the periodic table. Okay, here we go, bromide as well. If it ends in ATE or ITE, okay, it is going to be a polyatomic ion. You're going to be looking to your list to find the formula. This Roman numeral right here, this tells you, I'll just come down here, Roman numeral, okay, tells you the oxidation number of the cation. So on those elements on the periodic table that have more than one oxidation number, okay, it's actually in the name. Do you want me to make that a little bit bigger, Noah? A little bit bigger. So if you look on your periodic table and you find copper, you're going to find that copper could have an oxidation number of 2 or 1, okay? If it is a cation that has variable oxidation states or the oxidation numbers, it's going to tell you in the name, okay? So this means that copper has a +1 oxidation number. Iron has a +3 oxidation number. If there is no Roman numeral, that element has only 1 oxidation number, okay? So sodium is found in group 1. All group 1 elements have a +1 oxidation number. So we don't need a Roman numeral. We only need a Roman numeral if the element has more than 1 oxidation number. And it's only going to be the cation. It will never be the anion. Okay? Okay. So this is how we write formulas. So we are, like it says right here, we're writing formulas for binary and ternary ionic compounds. This is the first thing you're going to do. You're going to take a look at your cation, and you are going to write the symbol of the cation. Now I'm up there in the corner. And then you're going to take a look at your anion. And in this case, they're both elements. Chloride is going to be chlorine. So I'm going to write the symbol of my anion right next to it. So right now I've got MgCl. MgCl. Now I'm going to assign oxidation numbers. So what's magnesium's oxidation number? I heard it. 2+. And what's chlorine's oxidation number? -1 is correct. So chlorine is a group 17 element. All of those elements in group 17 have a -1 oxidation number. Once I've assigned my oxidation numbers, can everybody see that? Are we good to go? Okay. After you assign oxidation numbers, if you sum them up and they do not equal 0, we have to add subscripts. That means we have to add atoms to our formula to make sure our oxidation numbers equal 0, because all compounds and all molecules are neutral, okay? So right now, magnesium has a +2 charge and chlorine has a -1 charge. So do I need more magnesium ions or do I need more chlorine ions? I need more chlorine ions. So how many chloride ions do I need to balance out my +2 charge for magnesium? I need 2. So I'm going to add a subscript 2 right here. So my correct formula for magnesium chloride is MgCl2. The oxidation numbers are there simply to make sure that your formula is correct. If you feel like you can do this without assigning oxidation numbers, you don't have to write them up there. They're just there to help you. So silver bromide, so silver is going to be Ag. Bromide is bromine, so Br. What's silver's oxidation number? Very good. And what's bromine's oxidation number? Very good. Do we need any subscripts? He's done and dusted. Aluminum sulfide. So Al sulfide is the element sulfur. So S. What's aluminum's oxidation number? Good. 3+. And sulfur? Awesome. Okay, we've got to add some subscripts. So what is going to be the the smallest number both of those can divide into evenly? 6. So how many aluminum ions do I need? And how many sulfur ions do I need? Awesome, very good. So 3 times 2 would give me -6 overall charge. 2 times 3 gives me +6. When I add those two together, it equals 0. Okay? Okay, let's look at copper 1 carbonate. So copper is Cu. That Roman numeral 1 tells me that copper has a +1 charge. Your quiz?
Yeah, do you want me to just come back here?
I just need your backpack and your phone in here. All you need is your handwritten notes and your periodic table.
Okay, I'm gonna go tell my teacher.
Okay, cool. Okay, so that Roman numeral 1 tells me copper is +1. Carbonate. That's not an element. What is that? Awesome, polyatomic ion. So what's the formula? We're going to just write the formula for carbonate. CO3. And that entire ion has what charge? -2. So you have to think of it this way, you guys. You've got one ion here that has a +1 charge, and you have another ion here that has a -2 charge. You have to group them together like that. So basically, I have a monoatomic ion and a polyatomic ion. So do I need more copper or do I need more carbonate? I need more copper. So what subscript goes next to the Cu? 2. So Cu2, CO3. Calcium phosphite. So calcium is Ca. This is where yesterday's stuff comes into play. You don't have phosphite on your list, right? But what do you have on your list? You have phosphate. So if it ends in ITE, how's my oxygen altered? -1. So what's the formula for phosphite? Very good. So PO3, that whole thing has a -3 charge. Calcium is +2. So we got to add some subscripts. They both need subscripts. So how many calcium ions do I need? 3. Now, anytime you have more than one polyatomic ion, so if we have to add subscripts like we do, you have to encase the polyatomic ion in parentheses. So since I have to have a subscript 2 next to my phosphite, I have to put my phosphite ion in parentheses and put a subscript 2 on the outside. So iron 3 oxide, come over here, is Fe. The 3 tells me that iron is +3 in this case. Oxide is oxygen, and it's -2. So who needs subscripts? Both. Iron needs what? Let's go with iron. Yep, 2. And oxygen needs 3. Let's just do sodium persulfate. And I think we're good, right? So sodium is Na. Persulfate. So per, does it mean less or more oxygen? 1 more. So you need to find sulfate, and we're going to add 1 oxygen to its formula. So the formula for persulfate is SO, is it 5? Right?
Well,
So
it's 4 on the paper.
yeah, but this is persulfate. So we need SO5. Sodium is +1. Persulfate is -2. So do we need more sodium or more persulfate? We need more sodium. So I'm going to put a subscript 2 here. So again, 2 times +1 gives me +2. And now my oxidation numbers equal 0. Let's do number 9. Just so you guys can see one of those. That's ammonium sulfate. So what's ammonium's formula? Thank you, NH4. And sulfate, we just found that one, is SO4, right? Ammonium is +1, sulfate is -2. So who's going to get the subscript? Is ammonium going to get a subscript or sulfate? Ammonium. So what do we have to put around ammonium? Good. We put our parentheses and we put our subscript too.
You also write that as insulation.
No, because these are true ions. So the NH4 acts as one single unit. So we're going to keep them separate. And then the SO4 acts as one single unit.
Okay.
Does that make sense? Yeah.
How did you get the 2 again?
This guy right here.
Yeah.
So sodium or ammonium's got a +1 charge, and this whole sulfate, this whole thing is a -2. So I have to have 2 of these to balance out that -2. So 2 times +1 would turn that into +2, and now they would equal 0. Okay. Have you guys done this before?
No.
No? What do we think? It's not too bad, right?
Yeah.
We'll practice.
What number 8?
Number 8, that's a good question. BaO. Because barium is +2 and oxygen is -2. So that would be BaO. Almost. Now we're going to go in the opposite direction. Yes. Now we're going to go in the opposite direction. So now we're going to be given the formula and you're going to come up with the name. So I'm going to have you guys do the same thing. I'm going to have you write my examples down. And then, oh, I guess I'm on the opposite side. And then we'll go through them. You need your periodic table. You have that back there?
Mm-hmm.
Awesome. And you have your handwritten note? And did you turn in your packet of homework?
No, I don't think so.
Let's go dig your stuff out.
Oh. This makes me feel really dumb. I only just I'm bad at math. If we have 2 assignments, I'm like this week because I haven't been especially since I'm in the yard tomorrow. I don't believe it. What did you just say? Nothing. I asked Facebook people. Oh.
Okay. Are we good? Do we need a few more minutes? Good. See if I can move it over. Okay, so now we're going in the opposite direction. Okay, so for your binary, so for instance, 1 and 2, These two are binary compounds because there's only two elements in it, okay? So when it comes to the binary compound, you are going to outright name the cation. So for number 1, I'm just going to name it as calcium. And then I am going to look at my second element, which is iodine, okay? But we're not going to write iodine. We're going to drop the INE, and we are going to make it IDE. So when those elements are in a compound, it's no longer ending in INE, it will end in IDE. So I'm going to take the root of iodine, drop the INE, and make it IDE. So it's going to be calcium iodide. Binary ones are super easy. Same thing here. I'm going to outright name my cation. Mg is magnesium. My second element is fluorine. I'm going to drop the INE and make it fluoride. And I may have spelled that wrong, so I'm going to put a question mark up there. Did I spell it wrong? Knew it! Is it
I think the
you?
first.
Yeah, you before.
I always
always
write
did the
it.
O first.
Yeah, I always do.
I don't
Ah.
know why they use first.
I always just tell myself it's not flour.
Whoever spelled that.
No, literally.
So I would think about that.
Because they were dumb.
You know, like, it's not flour. Shut up.
Okay. So number 3 is not binary because I have 1, 2, 3, 4 different elements. So this is a ternary compound. And if you remember, I said if there's a ternary compound, what is definitely in the formula? A polyatomic ion is in there somewhere. Okay? So I'm going to identify my cation, which is Na, and I'm just going to outright name it. So that's sodium. Since there's more than 3 elements, I know for sure there's a polyatomic ion. And in this case, it's HCO3. And we're just going to outright name it. What is HCO3? Bicarbonate. What you put in your cookies. Sodium bicarbonate. Now, so far, calcium, magnesium, and sodium have been group 1 elements. Okay? So they don't have more than 1 oxidation number. So we didn't have to bother with the Roman numeral. Okay? However, our next one, lead, remember how lead and tin have more than 1 oxidation number. So what we have to do is we have to keep an eye out for any cations that might have more than 1 oxidation number, because we're going to have to put a Roman numeral in the name. So I know that lead has more than 1 oxidation number. So I'm going to work backwards, and I'm going to figure out what its oxidation number is, because lead could be 4 or 2. So I got to see what it's bonded to, and I'm going to work backwards. Okay? So oxygen, we know for sure has a charge of -2, right? So if my 1 oxygen atom is a -2 charge, I only have 1 lead. So what does its oxidation number have to be? Has to be +2 to balance that out. So I'm going to put the 2 in Roman numerals. So I'm just going to name this guy outright, lead. I know lead's oxidation number is 2, so I'm going to put my Roman numeral 2. And then I am going to take the root of my anion and add IDE. So that's lead 2 oxide. Yes. No. No. And I'll go back and forth. I always feel like when I'm typing up a quiz, I know I don't have to capitalize it, but I just feel like I have to, you know? But no, that's a good question. Okay, so Fe is what element? Iron. Does it have one oxidation number or more than one? It has more than one. So we're going to have to work backwards, okay? It is bonded to a polyatomic ion, okay? Now, if you want, you can always do this. You can put your parentheses and leave it blank. And we can name the anion. So what's OH? I heard it, hydroxide. So you could do that. You could name the cation, leave your parentheses blank, name your anion. And now let's go back and figure it out. Okay? What's hydroxide's oxidation number? -1. But I have 3 of them, right? So all of them together have a -3 charge. So if I only have one iron atom, what does its charge have to be to balance it out? Has to be 3, okay, to balance it out, because all compounds are neutral. So I'm going to put Roman numeral 3 in my parentheses. And I could be wrong, but I think on the bottom of your polyatomic ion chart, there is a Roman numeral little guide, isn't there? All the Roman numerals? Okay. Hydroxide. Yep. Because OH is a polyatomic ion. So the OH together is hydroxide. Okay, let's do a few more and then we'll give you your assignment. We'll just see how far we get. Ni is what element? I heard it. Nickel. Is nickel going to need Roman numerals? Yes or no? Hello?
I can't find it.
Oh, okay. Still finding it, and I heard yes. So let's leave our parentheses blank. PO2 is going to be a polyatomic ion. So now we have to figure out what polyatomic ion it is. Now phosphate is PO4. So if we have 2 less oxygen, it's going to be hypophosphite. Oh, you guys, it'll get so easy. Trust me. Once you start doing this.
Did we get this on the test?
Yeah.
Okay.
Okay, so now we have to go back and we have to figure out the oxidation, or we have to figure out the Roman numeral. So hypophosphite, what is phosphate's charge? -3, right? But see how we've got 2 of them out here? So 2 times -3 gives me an overall charge of -6. So if we have 3 nickel atoms, each nickel atom has to have a charge of what? 3 times what is 6? So nickel has to have +2 charge. So my Roman numeral is 2. Let's jump down to, let's do 9. Well, do you want to just do the rest of them?
Yeah.
Okay. Let's do the rest of them. Ag is what element? Silver. You got to get in the habit. Check to see, does it need more than 1 oxidation number? Or does it have more than 1 oxidation number? So Roman numerals are not needed. So now we're going to move to the anion. Okay? And again, if you have 3 or more elements, I guarantee you there is a polyatomic ion present. So I would never name this silver carbon nitrogen. Okay? I guarantee there's a polyatomic ion in there. So what polyatomic ion is CN? Cyanide. So silver cyanide. Okay. What element is Cr? Chromium. I think I spelled that wrong as well.
Oh,
No, you spelled it
Did I spell it right? Okay. Does chromium need Roman numeral, yes or no? It does. Let's move to the second element. We'll come back to the Roman numeral. Cl is chlorine, so we drop the ion E and make it chloride. So let's work backwards. What's chlorine's oxidation number? -1, but I got 2 of them, right? So 2 times -1 gives me an overall of -2. So my one chromium atom has to have what charge? Has to have +2. So I'm going to put 2 in my Roman numeral. Last one. Sn is what element? 10. Is he going to need a Roman numeral? Yes or no? Yes. We'll come back to him. Let's name SO5. Well, SO4 is sulfate, right? So if I have one more, it's going to be persulfate. Now let's work backwards. Persulfate's oxidation number is what? -2, but I got 2 of them, right? So 2 times -2 gives me an overall of -4. So what does my 110 atoms charge have to be? Has to be 4. And that is VI. IV. IV. Oh my God.
Yeah, VI is 6.
You guys learned any chemistry this year, I'm hugely surprised. Okay, so I know it's a lot, especially if you didn't have any physical science, and if you had physical science 2 years ago, then you were probably, we didn't even go through this because of COVID. So I know it's new. We're gonna practice a lot. I had originally planned on 2 assignments today. We'll just do 1 today. And then we'll do some whiteboarding tomorrow, and we'll just practice. Okay, we'll just practice. Okay. So for those of you who are gone tomorrow, there'll be some whiteboarding problems on Google Classroom, and then I will give you the homework assignment from tomorrow as well. Okay. Okay. I'm going to give you 5 minutes to process that. I'm going to pass out your assignment, and I think you'll be able to get most of it done. Daniel, could you turn on the lights on your way out? Thank you. Yeah, both lights.
That was just yesterday.